Welcome, dotnet friends. It is a new week, and with that comes another episode of what you're here for, the On .NET Live Show. Our mission here on this show is to empower all of our .NET community members, that's you, to achieve more. I'm your host, Scott Addie, and I'm joined by co-host Maira Wenzel. And
Hello.
We have a return guest. You may have seen our guest on previous episodes of the show, Vahid Farahmandian. Vahid, would you like to introduce yourself to the audience?
Hello, and good morning, good afternoon, and good evening for everybody around the globe watching us again in .NET Live TV. I'm here. I'm back after, I think, after 3 years. I'm here to talk about Jinget source generators and discover some interesting things that we have faced in the past and solutions we find currently in our ERP systems. Scott, I'm here with you and Maira. And I'm here and I'm ready. Okay.
Awesome.
All right. With that, why don't we get right into the content? I know you had some slides you wanted to start with, so let's start there.
Yeah, let me. Okay. Okay, may I start? Ready?
Yeah,
we're ready.
Great. Okay. Before starting talking about the source generators in Jinget, I would like to tell you the evolution story of Jinget, where we were in the past and where are now currently. If you have followed our previous sessions .NET Live or previously .NET Docs show, we have introduced Jinget in one of .NET Docs show called Look at the Middle East's largest maritime ERP system about 5 years ago. Several years ago, while developing an ERP system, we realized the need of our own framework, one that would only accelerate development, but also enforce our architectural principles too. We start by building this framework on .NET Framework, which despite its strength, imposed certain limitations to us too. That was the reason that we make a decision to migrate from .NET Framework to .NET, and that was where the Jinget was born for us. Jinget primarily started with the domain-driven, design-centric styles, and after that we added the support for CQRS for Jinget. At the first steps, we realized that we need to separate the routes for command and the queries because we had the SQL Server always on our database backstore, and we need to separate the requests based on their types. That was why we considered moving to CQRS. At the earlier stage, we used the Dapper as our query side handler, and in the other program which we have presented on .NET Live TV, I think about 2 or 3 years ago, we took a look at the Jinget Dapper module where we had a transformer and translator to translate the C# codes to TSQL codes. After sometimes we consider that EF core, Enter Framework core, boosts its performance and it's nearly is better than the Dapper. So we decided to change our query route and put the support for read-only models and read-only Enter Framework DB context besides the Dapper. That was where the source generators comes into the Jinget's body, and we start developing the source generators to make benefit of it in our read-only routes. But this is not the whole story. When we started to make use of the source generators for our read-only routes, we considered that we have many duplicate codes. For example, we write some models to save our data in our write or command routes, and we need to duplicate that model code in our read-only models code. We need to duplicate the Entity Framework mapping configurations for our read-only models, and that was not very interested for us, because one of the goals that we were casing about is that we need the speed up the development time. So writing the duplicate code is not a great option for us. So we started discovering the source generators to write something that transforms our models to read-only models, with source generators that generates the mapping configuration, and even the source generators that can completely write the whole application for us, completely write our web APIs, consider our architectural decisions, write our mapping configuration, and read-only models. That was the goal that we were interested to achieve it. And currently, today, we achieved that in the Jinget source generator modules. Today, we have open sourced numerous modules of Jinget, such as Jinget Core or Jinget DI Scanner, which automates the dependency injection scan in the whole application. The external service handler, which is responsible for communicating with the external web services, Jinget Logger for logging the requests and responses, exception handler for central exception management, and the source generator, the newly open source module for Jinget. It's really new. We have open sourced it, I think, yesterday. Yeah, we have yesterday open sourced it, and the audiences can start using the Jinget source generator. Up until now, Jinget has about 120K downloads on NuGet. Of course, you can get this source code by going to my GitHub profile located github.com/Vahid/Jinget. The whole source code is there. Again, I would like to repeat that this is not the whole Jinget. These are some open source modules for Jinget. There are other modules for Jinget that are not currently open source, but we are on the way to make the whole Jinget open source for the audiences. Today, we're going to discover the Jinget source generator module and see what's going on it. The source generators and Jinget all together provides us the fast development with CQRS plus domain-driven design, architectural style, and architectural services. Nowadays, we do not have any boilerplate codes, and we have a future-ready architecture in the whole applications. The key takeaway that Jinget gives us today is the automation and unlocks scalability for us, and that's very great for us. Of course, it's very great for the large teams which are developing ERP systems that needs to ensure the architecture throughout the whole application's source codes. It's very great benefits that Jinget can take us. For the future, our plan, of course, we are seeking the to use of the more code generator in our Jinget frameworks. Of course, why not? But we're just seeking for that potentials. Okay, if you are ready, we can go back to the Visual Studio and explore some source codes and see how source generators are going to work and how they are going to be configured during our source codes. So let's get back to the Visual Studio. Okay, here are
before you start that, Vahid, I was curious in terms of if you could just give a brief reminder for folks that maybe didn't watch the show or maybe need a reminder, a refresh of like what are kind of the best use cases for Jinget and like what does it do like in a very like
I think Jinget is best suited for the teams that are going to develop ERP systems, the large scale software systems where we need to consider the architectural through the all submodules of ERP system. One of the challenges that we face in developing larger scale systems is that after time passes, the modules architectures become different from each other and the codes are getting boilerplates. This where Jinget can help us by the use of source generators or other modules. It's completely design a big picture for your application and big picture for your application's architecture, and the developers should follow that instructions, and they cannot do any innovations in the application development. Of course, limiting the developers' innovations during the application developments could be a strange or could be a bad thing. But I think during the development of large scale systems, limiting the innovation can be a great point, because these innovations during the time might convert our applications or application source code to a boilerplate code or spaghetti code can becomes in a place that might be very harmful for applications. So for larger scale softwares, Jinget can help the applications. Second use case for Jinget that I love it is for the teams that are seeking to develop an MVP or minimum viable product of their idea. They are going to work on the front-end layer, and they do not want to consume a considerable time in the backend sides. But of course, they need to have something in the backend where where Jinget source generators can accelerate their development for the backend. I will show you that in the backend, the only thing that team needs to define is a model. After defining the models or after defining the entities, the whole source code will be generated automatically, including the web APIs, command handlers, query handlers, even domain services, and the domain business logics. They all can be generated automatically by the frameworks. I mean that with 10 or 50 minutes, you will have a complete backend web services. Then you can switch back to your front end and start working on your MVP version of your product. So for the startups that are seeking the fast to market times, Jinget again can help them in that steps.
Awesome. Yeah, no, I think it's just set the context of how it can help our viewers there that are looking for that kind of source generated tool. All right. So as Frank says, let's see some code.
Yeah. Yeah, let's see what's going on in the codes. For example, suppose that I have some models defined in my source code. I've started with the student model. Let's ignore this part and think about this model as a bare model. Okay. When I'm working with an entity or model in domain-driven design, I might face something like this, where I have a properties that I'm going to map these properties to the columns in my table. Maybe my model might have a base entity, which provides the base functionality or base domain-driven base rules to our entity. And a marker interface might be exist there that defines the aggregate rules from the sub-aggregates or sub-entities in our model. This is what we have in the domain-driven entities. I'm going to convert this model to the read-only model using the Jinget source generator. First step to achieve this is to put an attribute calling us the generate read model. When I put the generate read model attribute over my model, the read model generator starts working on that source code. It's going to scan the whole code and get all the models decorated with the generated only model attribute. After getting that models, it's going to create a new class based on my model class. But it would be weird to exactly convert this model to the read-only model. In the route of converting a model to the read-only model, we might need to add some new properties to our read-only model, or we might need to ignore some properties. We might need to preserve some data types and prevent them from transformation, and many other things that we might need to do during these transformation. That's where the other property of the read model generator comes to play. Let's see a full example. This is the whole attributes I have here. Okay. Now, what does this going to say me? It's saying is that I'm going to transform this model to a read-only model. The preserved base type calls me that during the transformation of a student model to read-only student model, do not transform its base type. It means that put the base entity exactly in the read-only model too. There are some use cases where we need to transform the base type too during this generation. For example, when I want to convert the student model to read-only student model, I need to convert the base entity, for example, to read-only base entity too. In that case, I need to say the generator that, okay, do not preserve the base type. But if I want to preserve the base type, I need to say, it's okay, preserve the base type and do not include in the transformation. Another property here, the whole attributes here are optional except the generate read model. So the first optional attribute here is append property to read model. This attribute helps us to append a new property to the transformed read-only model. I mean, this attribute tells me that after transforming the student model to the read-only student model, add a new property called is suspended, which its type is Boolean. So in the read-only student model, I will have a new property called is suspended of type Boolean. Another attribute here is preserve original getter or setter. Of course, using this attribute in the domain-driven centric applications for the query side or for the read-only use cases would be weird, but we are supporting this too. As you see here, I have a property called name here. The name setter is private. By default, the transformer will transform all properties as a public get and public setter properties. It will not transform their access modifiers. If I want to force the access modifier transformation, I need to put the preserve original getter or setter over the property to transform its custom access modifier to the read-only model too. Okay, let's simplify the example by removing this. I don't want to include it, and even I don't want to have the private here. As I told you, because it would be kind of weird things that we need to transform the properties as protected or private for the read-only model. Why? Because the main reservoir starts to converting the model to the read-only model is to get rid of the limited or get rid of the protected setted properties. That's why we're going to create a read-only model. We need to have the complete liability for all models where we can change the property values wherever we want. That's why we're going to transform the vertical. Another attribute here is ignore read model conversion. During the transformation, there might be use cases that we want to skip or ignore a property from being transformed to the target model. We can put the ignore read model conversion over the property to skip that's the property from transformation. So in the final read-only student model, we will not have a property called enroll date in that. Why? Because we have ignored it completely from transformation. Another very useful attribute is the preserve original type. We have many types in the domain-driven world that we do not want to transform them when we're going to create the read-only models. For example, we have value objects. Value objects, they might be a structure, they might be reference types. If they are reference type, their types should not be changed after transformation. Here I have a home address of type address. If I go inside it, it's a value object. So during a transformation, I do not want to change its type. I want to transform the home address as appeared in the student model. I can put the preserve original type over the property to prevent the property type transformation. There's one rule here. By default, Jinget source generator starts transforming all reference types. So if I want to
I think we lost him for.
Give him a minute.
Yeah. Hi, Vahid. We lost you for a second.
Okay.
You were explaining that by default, the reference type.
You have my screen?
Yes.
Yep.
Okay. As you might see.
It happens. We're live people.
Okay. I'll continue. It's not okay, huh? May I continue? Can you hear me?
Yes. Please, yeah. Please continue.
Okay. We have some limitations to access the internet in Iran. I'm very sorry about this incident. Okay, let's continue. Another attribute that we can put over our properties is the aggregation attributes. our models might have some relations with other sub models or other models. These relations could be one-one relation or one-to-many relation or even many-to-many relations. For one-to-many relations, one of the very useful use cases is to have ability to count the many sites records. For example, for student courses samples, consider this, that one students have many courses. In the target read-only model, we need to count the number of courses students could have. So we need to, again, append a new property, for example, called courses count, and use it to count the number of courses for a specific person. Besides the count, we have other aggregations too. We can use the sum aggregation, or you have access to maximum or minimum, or even the average attributes too. Conceptually, putting the courses count here, or putting the append property to read model over the class, both will result in same thing. So there are some syntactic sugar. In fact, they have no difference with each other. And these sum average are here. Okay, let's see what will going after running the generator. I have some unit tests for a read model generator here. In the unit test for my read model generator, I'm going to input the student model to the generator and start looking at the generated code to see what's going on to be generated. So let's debug the test and see the output, what's going on after transformation. Okay, we have the generated code here. Let's take a look at the contents of it. Let me copy this and put it in a screen where the font size are. Okay, this is the source code that the transformer produced for us. We have read-only student model here. So the other convention here, every model that needs to be included in the transformation should end with model, and the transformed model will be start with the read-only prefix. I have read-only student model here. The base type of my model is base entity because I told it to preserve the base entity. Also, I have access to my interfaces here too. We have name here, or let's check it one by one. I have told it to ignore the enroll date. As you see here, we don't have enroll date here. We have told it to preserve the original type for home address. Okay, this is a home address of type address value object. It's fine again. We have told it to append is suspended and the courses count and the sum of scores and average scores to our model. And we can see that newly appended properties to our class. Here's courses count property, sum of courses, average courses, and is suspended property that are appended to our code. So we now we have access to the read-only student model. After generating the read-only models, the next challenge will arise. When we define the models, we have configured them in entity framework mapping configurations. In entity framework, we configured that, okay, DB context, go and explore my models and map each model to a table and their properties to the columns of the table, and then lets me start working with it. Now that I have read-only models, I need to tell the entity framework that, hey, entity framework, I have models for the DB context, and also I have read-only models that I'm going to use for the read-only rows or read-only requests. This is where the generate read-only mapping configuration comes to the game. For the read-only mapping configurations, consider that, let me open a test. Consider that we have this mapping configuration, this entity framework mapping configuration sample. Every mapping configuration should implement the entity type configuration interface in any its levels. The class could implement this interface directly, or a class could inherit it from a base type that implements the interface. It's not important. the important things here is that the class should implement this interface in one of its parent tree nodes. Okay, I have my mapping configuration here implemented in the time framework. The configure method comes here, and I have access to builder where I can config the builder. For example, I told that, okay, map my student model to the student table, and there are many-to-one relationships between student or scores, score models, or I have, I don't know, a name property that I'm going to consider it as in varchar 50 while mapping it to a table in a SQL Server or any other database that I configured. And also I have a many-to-many relationship in my student model. Okay, I need to transform this mapping configuration to a mapping configuration friendly to my read-only model too. In order to transform this mapping configuration to read-only model, I need to put the generate read model mapping configuration over my class, and by putting this attribute over the class, it will generate the read-only student mapping configuration from our source code. The only important thing here is these comments. In these methods, the comments with this convention have meanings for us during the new source generation. When we put read model mapping, ignore this line comment over a statement during the transformation, we will ignore that statement. I mean that when I want to transform the student mapping configuration to the read-only student mapping configuration, it will start reading the methods and all its statements one by one. Each statement that comes with this formatted comment, it will ignore that statements. So in the target read-only student mapping configurations, we will not have these statements in that class because we are going to ignore this statement from it. It's very simple to transform the mapping configuration to read-only mapping configuration. This is why the read-only model transformer, the mapping configuration transformer, is very simple to understand and to work. Okay, Maira, I'm with you.
Yeah, sorry to interrupt. So I was just curious. So did Jinget created this mapping configuration for you based on your data source, and then now you're just tweaking some of the things that you need there?
No. Jinget does not create this mapping configuration. These mapping configurations are things that we're writing on our own. Jinget does not create. And I think it would be a bad thing to rely on Jinget to create the mapping configuration for us, because the mapping configuration should rely on our experience and requirements and our target database. In some database, in some requirements, in some scenarios, we might define an index, or in other scenarios, we might ignore defining an index. This is why we skip the mapping configuration generation in Jinget. Jinget just transformed this mapping configuration to the read-only mapping configuration. So let's see what's going on the test. Again, in the unit test, I'm going to import the student mapping configuration and start transforming it. So let's see what's going to be transformed. Just stop the previous unit test and start the new set. Okay. Again, let's copy this code and put it on the screen and see what's going on there. This is the source code the transformer generated for us. Just like the read-only model generator, we have a class prefix with read-only and the name of my class. It's implementing the interface. During the mapping configuration transformations, it also transformed the models in my source code too. In fact, it starts to analyze the syntax tree, and wherever it faces a reference type that have been transformed during the read-only model generation, it starts to renaming them too. As you see here in the student mapping configuration, we have a student model here. It's a class. It finds this in syntax tree. Student model are a class that can be converted or transformed to read-only model. So it transformed it and renamed the class to read-only student model too. Again, we have the configure method, the rename the student model, generic type here. I have my to table here, and as you see, we have the read model ignore this line. I do not have these statements here. I have two statements here, one for mapping the many-one relation between student and scores, and the other for mapping the many-to-many relation between students and courses. This is the many-to-one between the student and course, and it's the many-to-many between the student and course, and this statement has been ignored. So exceptionally here, the comments have meanings for us, so do not remove these comments in the source code. The folks that are watching this video might consider replacing the comments with other syntactic sugars or other techniques. That would be great options to contribute to the source code, improving the solutions of these sections. But up until now, we found the comment the only solutions to find the statements that we are going to ignore during the compilation of our source code. Finally, after transforming the models to the read-only models and putting the mapping configuration beside the read-only mapping configurations and designing the command and query routes, after achieving this step, we thought that, okay, we have everything set up in the scenario. Why we do not go and create the web APIs automatically based on the models too? I have models. I know that my web APIs in many scenarios have some constant operations. They consist of get operations, I don't know, post, put, delete, or find operations. Okay, when I have these 5 constant operations, I can create the web APIs based on my models configurations. That was the reason that we start developing the web API source generators too. In order to make use of web API source generator, the only thing that we need to do is to put the generate web API attribute over the model. Any model having the generate web API attribute over it will generate an extension method which cause us to map the routes as a group of routes to our application builder host of the static core web API applications. Before diving into the generate web API attribute, first let's see the test, what it's going to create, and based on what it has created, we can explain in depth that what it's really going to do. I have, again, unit test here. I'm going to import the student model to the web API source generator, and okay, and let's start the unit test to see what it's going to generate for us. Okay, here our final source generated source code. Let's copy it on the screen. Okay, as you see here, we have an extension method here called map students API. The student word here is extracted from a student model. It's remove the model or read only of the strings and put the other things as a name of the methods. We have map student model here, and we have some predefined HTTP methods here. For example, map post to the root of Addie route, or map put, delete, get a list, or delete a list. Let's see what's going on in map post. In map post, we have injected a base command handler interface, which is responsible to route me to the command side and routes me to the command DB context and routes me to the database, which I can change its data. During the post operations, I'm going to create a newer source. I'm going to create a new record. So I need to go to the command handler side. Okay, it's injected the base command handler for me here. It's my command. It also injected the read-only student model as view model here. The reason it injected the read-only student model is that from the front-end side, it gives, or the front-end sends the read-only student model to me. During the post operation, I change the type of read-only student model to the student model, and then save that model in the database or do the business operations based on that model. I have the save async operation here that I need to implement this save async method, which is defined in base command handler, my downstream classes. For put and delete, these scenarios are exactly the same. For get operations, I've injected the read-only query handler here with respect to the read-only models or the ID to find the specific record, or the get list, which has query handler injected to it with the pagination options here, that I can start paginating my data based on the imported arguments, and finally the map list, which give me access to delete the list of records. And this is what the map web API created for me. But how does it create this bunch of code for me? In fact, the generate web API is not as this is not simple as it is appeared in the screen. Generate web API comes with numerous parameters. The first parameter here, as you see, is the claim prefix. We have some web APIs or web API resources that we need to protect them from public access. We need to only give access to authorized users. In order to give a web API access for authorized users, first we need to put the authorized attribute on the web API. This is where the has claim argument come to play. Any API which has claim attribute on it will be considered as authorized attribute. After these steps, I need to define that, okay, a specific user can a specific user is authorized to access the resources, but is that specific user authorized to access the specific resource too? For example, I have a user called Vahid. Okay, I know Vahid. He's totally authorized. Okay, but does he access to call the folder API too? In order to prevent this, in order to categorize the resources, we need to define claims for each of these web APIs. The claim prefix here helps us to define a better convention-based claims for our web APIs. Claim prefix appended to the claim title, the second argument, and makes the final claim for our resources. A claim type argument defines the claim type we need to put on our resources. In some scenarios, I might need to put the authorized attribute on my resource. In some other scenarios, I might develop my own authorized attribute. So I need to introduce my custom authorized attribute as a claim type to this generate web API attribute. The other argument here is command handler. As you saw, the generated source code has some injected services. For the commands, IBase command handler has been injected, and for queries, IBase query handler has been injected. By considering the command handler argument or query handler argument, you have access to change these default services too. The model here is used to replace the model injected through our source code. Exactly the same for read-only model. We can change the model and read-only model as our specific needs. By default, model will be the base model, here student model. Read-only model will be the read-only transformed version of our model, here read-only student model. By default, command handler will be IBase command handler. The query handler will be IBase query handler. We can change the whole 4 options here. The other 3 arguments have their specific use cases and scenarios. Consider that we are developing a tenant-based applications that we have, for example, different databases per tenant. By defining the tenant-aware argument here, we can tell the web API generator that, okay, generate the web APIs by having the tenant awareness in your mind and decorating the web API based on this argument. Trace data type is used to for models that we need to trace their chains, to know who created records, when the records has been created, who last modified the records, or the other trace data types we might need to import it through our model. If we have a trace-enabled model, we need to define the base trace data type, that, okay, our trace property, the type of our trace data is of which classes. That class should be introduced in trace data type. And the final one, the user context type. For the trace data types, we have a class called user context. User context used to decorate the user profile for us. What's the username of the user that authorized and is going to call our web API? The user context type is a class which gives me information about the logged in user. That information will be used to populate the trace data, because the user that logged into the system is user that's going to create a resource, is the users that's going to modify the resource. This will be useful for the trace-based data type. In our current sample, we did not go through the tenant awareness or trace data type. So the last three arguments were a bit useless in the last sample. Okay, as we have time box here, I would like to finish my presentation here. This is the whole story of the Jinget source generators. You can get access to the source code of the Jinget source generators and the source generator section in GitHub by referring to the github.com/Vahid Farahmandian/Jinget. We have open sourced the Jinget source generator model for you. You can explore the source codes, and if you like, you can contribute to the source code to make it better and more useful based on your own requirements. Okay, Scott and Maira, I'm done. I'm here. I'm going to get back to you.
We do have a question in the chat here. I'll pop it up on the screen. One of our viewers is asking why source generators in Jinget instead of something older, the text transformation with T4 templates. Any thoughts on that?
T4 templates, I'm not a fan of T4 templates. I think it's it reminds me the hard days of using the dotnet framework. I'm not a fan for T4 template. It's of course very useful, but in my opinion, from the performance point of view, the source generators is not comparable to the T4 template files. We have the full freedom in decorating our source generators. We have access to the generated source code. During the development time, I have access to the IntelliSense of my newly generated source code. These are things that the source generators provides me in better way compared to the T4 templates. This is my answer, and I said that really I'm not a fan of T4 template. It might be the main reason that we did not go through the T4 templates.
Thank you for that answer. Another question here. Speaking to more of the performance aspect of things. So when you're using source generators in the way that you are, what's the impact on compilation time?
We need to consider this, that when we are using the source generators, the compiler will compile our newly generated source code and attach it to the whole source codes that will be available after the compile time. Theoretically, this is correct. But when we are working with IDEs such as Visual Studio, you should consider this, that while using the source generators, it will start compiling and building our source code in parallel time with our coding time. This might have bad impact on the performance of your system. So during the development time, using the source generator, using a heavily source generator, I mean the source generator that have the high cyclomatic complexity will harm your system or will harm your development time or compilation time. But after it's been compiled, everything will be normal and start working correctly and okay. But before the compile time, you should consider that, yeah, it has a negative impact on the performance during the compile time, of course. And especially while working with the heavy IDE like Visual Studio, it might be a thing that you should consider about it. But after compile time, the performance it provides to you is not comparable to the other solutions. If you remind that in the Stone Age, we have the reflections. We use the reflection for achieving the same things. The reflection was really, I should confess that I was a big fan of reflection. Despite the T4 template, I really in love with the reflection, but the use of reflection has a bigger cost and has very negative impact in the runtime. The runtime is the time that end user interacts with it, but the source generator has a bit limited cost in the compile time or before compile time. So this is the answer I can give about the performance points of the source generators that you should consider. Again, as a short answer, a final note. Please note to this that while writing the source generators, you might need to forget everything you know about the C# and .NET up until now, because you should go with the Roslyn syntax. You should avoid using the things like reflection. Of course, reflection is not available, and a compiler will give you error if you want to use it. But you should prevent using the high cyclomatic complexity codes. High cyclomatic complexity codes, I mean using the inner loops or having the, the recursive methods. These are very bad things for the source generators that might disturb you or might have negative impact for you. Yeah.
All right. We've got many more questions coming in here. This is awesome. I'll pop up the question from Jason here. And Jason's asking, why do you use create syntax provider instead of for attribute with metadata name?
Yeah, using the attribute with metadata name, of course, is a better way compared to the create syntax provider. I told you that we have open source Jinget just yesterday, and this is the old version of source generator that we have just tried to make it ready and make it open source to available for everyone. There are many things that we need to consider in the newly open source version of the Jinget. Of course, we will go through the attribute metadata name and other things in the source generators too. The only things that we changed in this transformation is changing the base interface for source generators. Prior to .NET 8, we have the R source generator, and currently we have I incremental source generator. We have just transformed to the incremental source generator, and of course, we need to adopt the source code with the newly capabilities too. Yeah, that's true. We have it in mind.
We do. There was a question before Jason's that I'm just noticing now. I'll pop this up on the screen as well. It's asking, so Jinget truly does use Roslyn source generators. Yes, it does. I'm wondering, maybe this is an opportunity to bring Visual Studio back up and actually show where the source generator is being used.
Yeah. For example, let's go with the read-only source generator. As you see here in our read-only source generator, it's based on the Roslyn source generator. We're going to call the generate source methods here. It's our main method. We're going to discover the classes that needs to be transformed and find the generate read model for type here. As you see that we have prefixed the read-only to our type here. And then we're going to discovering the inheritance tree and decorate the inheritance here. Then we're going to generate the properties for type, and we're going to appending the properties for types, and finally generating the new source code here. Well, let's go to a sophisticated one. For example, for Web API generator here. For Web API generator here, we have the generate Web API source code here, which is simpler than the previous one. It's going to discover the types, which has the generate Web API attribute over them. After finding the types which are going to be transformed, it's going to create a class for me called postfixes with API extensions. It's going to find the key property. The key property is important for me to create the Web API resources, which needs to inject which needs access to ID arguments to filter a specific report. So I'm going to find the key property here. I'm going to construct the command handler, the query handler, construct the claim section, tenant awareness, and finally construct the final source code here. As you see, it's not very sophisticated. I think it's very important to solve the problems as simple as with using the simplest available solutions. And this here, as you see, that we have the target source here, which is going to generate it based on our discovery, or for read model mapping configuration, the story is same. As you see here, it's going to again find the types, checking some business rules, and checking the types adaptability for using in the mapping configuration. And after finding the adaptable types, it's going to produce the final source code for us. It's going to analyze the type arguments, and if needed, transform that type argument. It's going to replace the ignore statements, remove other comments from the source code, replace the generic arguments. This method is the place where student model converted to the read-only student model. Or replace model names in method bodies. As you see here, if in the here students mode in the mapping configuration section, in the first student mapping, we have a student model here. So this student model inside our method body should transform to read-only student model too. This method used to transform that section for us. Replace the model names in lambda expression. If inside the lambda expression I refer to model, it's going to replace the lambda expression with the transform variable here and remove the extra white spaces in the source code. And finally, it's going to create the final source code using this formula here. As you see, the whole source generator is based on Rosalind, and there's nothing spatial or nothing complex here to discover. Everything is going to be as simple as possible. Beside these three source generators, we have main generator here too. The main generator is our start point to discover the application and generate the whole source code for us. Consider that I might have numerous classes in my source code. Some classes might have read model generator attribute, some other might have web API generator attribute, some might have mapping configuration generator attribute. Using the main generator, we're going to discover all of them and one by one start transforming the source codes using this generator. So the order of the source generator execution here is important. First, we need to call the read model generator to have read model, because read models are going to use in web APIs or are going to use in the read model mapping configuration. So if we have main generator, which is orchestrator for the other three generators, and the other three generators, each one is generating the specific source codes based on our requirements. So this is the whole source code. We can talk about it. If you need, I can dive it in deeper, Scott, or I can get back to you.
I think that explanation was just right. I see two more questions I'd like to get to, and then we'll wrap up the show for today. And the first of those two questions is this, and it's asking, are there project templates for clean architecture available that use Jinget?
If our audiences get back to the previous shows that we have together, look at the Middle East's largest maritime ERP system. In that show, we have completely discovered the suitable architecture based on the clean architecture, or even other architectural styles that might be suitable for developing large-scale systems. In that program, looking at the Middle East's largest ERP system, it was presented in the former .NET Docs show program. In that program, we have completely illustrated the architectural style and the templates that might be suitable for the largest applications.
Okay. And then the final question that I promised here, and this is a nice way to wrap things up. Thank you for teeing that up for me, Jose. For folks who have watched this show today, they're looking at Jinget and they're thinking, wow, that's great. Maybe I can use that in the project I'm working on now. What are some good resources they can use to get started with Jinget?
The main resource for getting started with Jinget, of course, is its GitHub repository. The folks can access that the GitHub repository, or even if they want to get access to the closed source section of Jinget, they can contact me using the email address or find me on any social media, LinkedIn, Instagram, or wherever they think. Every day I'm online on all of my social medias. They can contact me. I'm honorably can send them the closed source section of Jinget to them, and they can explore it, or even they can use it in their projects too. The reason that we are going to open sourcing the Jinget step by step, and it took these long times to open sourcing the whole Jinget, it's because of the Iran's internal rules. We have some private customers that we're not allowed to open source the Jinget up until some specific time in the future. But for the foreign customer, for foreign audiences, we can honorably give this Jinget source code for them freely, and they can investigate and start using that. But the only resource they have access for Jinget is the GitHub repository and the YouTube videos, which mainly presented in the on .NET Docs show. Previously, we have explored numerous sections of Jinget. I can recall that we have explored the gRPC module for Jinget on .NET Docs show, on .NET Live TV, sorry. We have explored its architectural in the .NET Docs show, the Dapper section in .NET Live show. So if they explore the .NET YouTube channel, they might have find some interesting videos about Jingets too.
Okay. And speaking of the .NET YouTube channel, you may have seen Jason Bach ask a question in the chat. Thanks for joining, Jason. We actually did a show last year, April, with Jason on the topic of source generators. Do check that out if you're interested in learning more about them. With that being said, we'll wrap up for today. I'd like to thank all of our viewers for tuning in, both new folks and our loyal viewers. We appreciate seeing you here. Today's show was recorded. You can check out other recordings of previous shows out on our YouTube channel. Go over to dot.net/live in your browser and check that out. We'll return next week, same time, and we'll be joined by Eric E.J. Jensen, an MVP, who will join us to talk about supercharging SQL development with modern .NET. Hope to see everyone then. Bye.
Bye.
Goodbye.